finish this sprint review from the projectile stuff. We're gonna change our change pace a little bit, and I'm gonna start working on custom gravity systems. So the idea here is please don't open. Oh, fuck. I was like, please don't open 50 tabs. Okay, so custom gravity system. Gravity influence zones. Zones that define a collision overlap zone area in which their gravitational settings take priority. Rules. Each zone is responsible. Zone implementation is responsible for updating gravitational direction. Okay, hang on. Each zone has a priority, integer priority. Priority. An object will take gravitational data from whatever zone it overlaps with, which has the highest priority. In the case that there are one or more overlapping gravity zones, for instance, a planet and a moon, that have the same priority, the gravitational acceleration of both zones will be calculated, summed for applying to the objects. So like imagine you have a big zone and a little zone, the moon and the moon and the planet. So we'll have different fall off methods. So in that case, it would be a squared fall off. So you're likely to have less effect from the moon's gravity than from the planet's gravity. But if you were to get close enough to the moon, at some point the acceleration from the moon is going to outpace the acceleration from the Earth because there's a square, like a geometric fall off of gravity as you get further away from it, right? Um, each zone has a fall off type. Um, exponential, linear, constant. And then like linear fall, so exponential would be how gravity tends to work in the real world. Linear is like it's just a straight ramp. As you get further away, you get less just linearly. I'm not sure we even need that one. It may just be exponential and constant. And then constant is good for gravity fields in like vehicles, for instance, because you don't care about fall off for the gravity of a vehicle that you're sitting inside of. It's too small for that to matter. Each zone is responsible has a mass um, um, a responsibility to calculate the gravitational direction for overlapping objects. Each zone has a responsibility to calculate the force operation overlapping objects. Each zone has responsibility for calculating gravitational vector, which can be velocities. We may make use of the directional gravity built into UE4 plus. Um, I don't know if I want to handle dampening, like movement speed dampening, in the gravity zone, or if I want to keep it simple. Um, we may potentially add other features to these zones, such as gravity driven speed limits, atmospheric dampening, movement damping. Let's see. Okay. So let's go to the drawing board for a bit and do a little bit of visualization here. So let's say we have two gravity zones. One is for a planet, and one is for a moon. And then we have another, nope, we have another influence zone. It's like our spaceship. Priority one. Priority one. Priority two. We're going to illustrate a couple of scenarios. Player ship. Player one. Player two. Let's do one more player out here. Player three. Out here in 0G. Okay, so let's take a look at how this works. So, to start with, let's take a look at player two because that's our simplest case. Player two is only inside of this priority one gravity influence zone for the planet. The planet will influence zone will have its own little custom logic. So it's going to have a center of gravity. It may calculate its gravitational acceleration based on mass. And what it's going to do is it's going to apply some degree of acceleration to player two. Damn it. Stop it. It's going to impart some form of acceleration to player two um, relative to how far max grav min grav. And then this fall off function. So at any given point, at any given frame, it's going to figure out where the player is relative to the surface, the maximum gravitational point, and the edge of the atmosphere where it's at its minimum, and it's going to do some form of interpolation of the acceleration value, and it's going to apply a force to this player towards the center of the planet until they land on the planet, and then they can run around. Player two is in between two fields, so he's actually getting pulled in two directions, right? And he's going to have one pull from the Earth and one pull from the Moon. Here, the zones both calculate acceleration changes and sum them for character. Okay, and then we've got this thing that's a ship. So the ship may have its own gravity applying to it as well, pulling it towards the center of the planet. But let's say we're flying the ship upside down, and we have another custom zone inside our ship, and it has a priority that's higher. And we're going to add a little player here. And for example, in this example, we could have no fall off, and our gravity direction could just be a constant, the constant down z vector of our ship object. It doesn't need to be um, it doesn't need to be like any more complicated than that. We don't have to have a center of gravity or anything. We're just going to push the character in the z value. Let's say that our ship was upside down, right? So our ship could be falling. Our character, once they enter into a zone, and this is what I haven't figured out yet, um, they're going to need to get attached to it, and then we're going to need to move them in local space so that you can like walk around on a ship that's also flying around. So you have to figure that out. And then like this player is just going to be pushed down to the floor. And then finally, um, if no influence zones, then 0G. Ship Z axis. Direction vector. A constant. Fall off. Okay. So I think those are our cases. And I mean, you could have as many overlapping zones as you want, although in practice you probably won't want to do that, right? It would be like, um, I'm going to have a solar system wide priority zero gravity zone around the sun. So, like, if you're not if you're not in a planet's atmosphere, then you would be like very, very minorly getting tugged towards the sun, right? But if you, as soon as you enter into like a priority one, it's going to take precedence. But then if at any given time this player checks the zones he's a part of and he finds that he's got this one and this one, then we have to blend the acceleration from both sides. And it could be potentially, and I'm pretty sure this would be real life too, if you had a situation where you were dead center in between two equally massive objects to where you had exact equal gravity forces on either side. You would just float there until like minor differences began shifting you to one side or the other, and then like the fall off would take care of it. And then, but most of the time, it's just going to be like whatever the highest priority zone you're in. So this is the idea. Um, 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 um. This is the idea, so let's get started, I guess. All right, so I often find coworker helpful at scaffolding this stuff out, so I'm trying to think of how to word this as a prompt to get us started. Trying to figure out what level we get access to gravity stuff. Child gravity. Um, that's a good question for coworker. Okay, I'm pretty happy with the projectile management systems. Let's move on to custom gravity. Um, what is the highest level class that has gravity attached to character movement component physics simulation? Enable gravity. Okay, so we basically. Wait, do we have this already? Maybe I'm just overthinking this. Physics fail. I don't see gravity on there. Nah, it's full of shit. Okay. Okay, so basically, I want to create a space system. Each zone will have a priority any gravity enabled objects. Check for overlaps with any gravity influence zones. It will then apply the gravity data from the highest priority zone to its own gravity simulation if there are multiple overlapping zones with priority their effects will be blended somehow. Not quite. No blend radius. Instead, all would be implementation dependent. We would calculate the direction, magnitude, both of all relevant zones, and then figure the actual gravity and vibration from combination relations. We know each influence zone should have a method to return. Area. Okay. So just on the surface, we know we want um, the gravity, yeah, vector position. Direction, gravity, acceleration. So to start with, we'll make one that is just Earth, right? That's 8.3 meters per second, roughly gravity, and a negative z-axis direction. Doesn't matter where the world position is. This would be a good example of like a spaceship gravity field where it's actually really simple. We don't have to do complicated calculations or anything like that. What else do we care about? So, would it be possible? So, like, what I'm really kind of struggling with is a way to make this flexible for different types of things. Like, we want to be able to use this. in our character movement. We want to be able to use this in uh, in our like physics objects. Okay, one thing I'm kind of struggling with figuring out, um, we the calculation of gravity for a given object should pretty much the same for all the different objects interact with gravity. I don't want to have to re-implement this every participating object in the system, but it seems to me that the actual calculation and blending of the data would be most efficient when done from the objects he is acting on rather than the zones. So the zones themselves just basically give a function that takes a world, maybe, or position within them and returns grab direction, acceleration, let me see. I, I'm trying to come up with a graceful to not have to recreate this logic for every actor that participates. I see. Let me add the gravity component to any object that we want the gravity to work with, and then the gravity. Yes, it can call on its parent. It can. Yes. Okay. Okay. Beautiful. Yeah, we can absolutely do it like that. So let's compile this. Compile this. Yes. I just learned about these. So I'm just thinking about this now. So I guess in the gravity component could set the owner object as whatever gravity enabled objects want the component to update. Then we could do a series of casts to all the types of objects affected by gravity till we find the right one, then apply our gravity reference. Okay. Okay. If owner has character movement components, as to character. Character to is it only static character type components, or are there other types that we need to Okay, yeah, we're not gonna worry about this quite yet. Um, don't worry about the projectiles. We have a way to handle that. Custom movement components. What about vehicles? We can disregard projectiles. Your system should already support what we need. Movement, 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 movement. Components. Yes. Which component? Let's see. That by event looping. Um, check create event. No. Custom event. Check gravity. I don't think we need to check this on the event tick. Like the projectile manager, it made sense, but here I don't think it really does. You don't want your projectiles only updating every tenth of a second. That would look really bad. But for gravity changes, it's probably fine. Um, sequence. Um, physics enabled. Gravity. Bridge. Just thinking. World. Location. Get location. Work. I can add an event to this thing's overlap. No, not yet. Okay, I'm working on logic in the gravity component given the location of its owner. How can I check any? How can I get list of actors its location overlaps with? All right. So would we ever need anything except for? No, no, no. Okay. So before we do any of this casting stuff, we can actually go ahead and calculate the gravity stuff. Check gravity, call get bounds on the owner, call sphere overlap after actors with the gravity influence filter. Okay, variables. Priority. We won't just overlap all. Okay. More traces. We don't need that. Okay, I think that's good. Priority should be exposed. Save everything. Let me see. Because it's not cast. Okay. Think. Thinking. Okay, so say I have done the query for overlapping actors, have an array of actors that are filtered to only include graph influence zones. Um, is there a performant way to select the nodes with highest priority in the array? Do I need to do a for loop? Okay, got it. So variables, thinking base priority would be like -1. Current highest zone. By default, it's going to be -1. do this. And delete. And fuck it. Okay. Awesome. Into those later. Default value is -1. Get it and set. Um, Current influence zones. This will be gravity zone. Has to Morty. So if the current priority is greater than the highest priority, clear. Add. If it's not greater, if it's equal, if it's equal, zone. Otherwise, do nothing. Okay, so we come in here, we get a big batch of these. We loop through them, we cast them. As long as it's successful, we check the priority against the current highest priority. If it's greater, we're going to set the current highest priority, clear the array, and then add the current influence zone to the array. If it was not greater than, or but it was equal, we're going to just add to the array. And if it's less than the current highest priority, then we don't need to do anything with it. That seems right. And then when this is done, we have our set of influence zones. So um, for each get function calculate gravity data. And then, like in this case, couldn't we? Think we could reconstruct the position and magnitude that we need from this, I think. So, like, think about it this way. Let's just assume this is going to be normalized. Okay, assuming gravity direction is normalized, then this gives us our gravity acceleration. Um, is there a if I am applying gravity a set by event good way to get deltas last time firing, or do I just assume it's the interval? It's probably fine. Let's just use the frequency. with a tenth of a second for now, but the important thing is that that is needed here. Simulated gravity vector. Do 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 do. All right, and then we can just actually, yeah, that was right. Get set head. Nope. To do it each time, like so. Okay. So we fetch our gravitational acceleration for our delta time. We accumulate it into a gravity vector that we cleared out before we started this loop. And then we set it. And then when this is all said and done, no, no, no. When all this is said and done, we want to get this, normalize, that's our gravity direction. Current direction. And we want to vector length. Current gravity magnitude. I think this is all right. Okay, now here's where we get to what I'm not super sure about. Um, okay, so for instance, character. See how I can set gravity direction. How can I set a specific gravity magnitude per So what I don't see is how to set like a specific gravitational acceleration. The most important part is the direction for characters because we're going to have to go in and make the changes to the C++ code to enable custom gravity characters again. I don't know if they might have fixed it in 5.5. I haven't tried it, but you used to have to change some animation shit uh, for custom gravity, and I'm probably gonna have to do that. But okay, so and then we could potentially apply our acceleration ourselves. UE 5.5 custom gravity third. This one is, I think, the one that I followed a while back. This is cool. I'm curious about this. No, no, no. Okay. 5 directional gravity. Man, people selling this as an asset. That's so stupid. Just do it yourself. This might be. This might actually be useful because it's going to show flipping the. I mean, if it's just flipping the direction, I need to know how to change the magnitude, but only for that object, not for all the objects. And if I can't do that, then I'll have to settle with just changing the direction in the custom object and then like applying force as an acceleration, which would not be ideal. All right, it's pretty neat.
Hi there and welcome into this tutorial. In this tutorial, I'm going to be teaching how you can use gravity manipulation in your game. So I'm going to be create a few abilities. The first one is to make an object like this one, to make it lighter like that, and then to be able to make it heavier like this. Now it is too heavier to move. Then to be able to disable the gravity of the object like that, and to enable the gravity again, and of course
Okay,
to change the
that's
gravity
pretty
of your
cool.
character itself like that. So this should take a few seconds and it's going to be enabled again. To do this, I'm going to be using the third person template. So as you can see, I have nothing created yet. And the way that I think about this ability is that you can use in three different ways. The first one being if you want to change how, let's say, if your object is a little bit lighter or heavier. And the second one is if one should
So
disable the
just
gravity for the object. So it's
changing the
zero
mass
or
is
not to have
not
gravity
like
manipulation.
it's whatever.
And the last one
It's
is
not
if
really
you
what we're
want to
looking for.
change the gravity in your character. So I'm going to be showing these three options. For that, first thing that I'm going to be doing is to create an object that's going to be the object that we're going to be manipulating. For that, right click, let's go actually to content, right click and blueprint class, select actor. This one is going to be our bd underscore object. Open this up And this is just for the demonstration. I am going to be adding a simple cube over here. You can use anything for that. And I'm going to be selecting here into simulate physics. So just
Gotta be
remember, with our cube
way too.
selector, go to simulate physics, and that's it. Now compile it, save it, and that's our object. I'm going to be placing this in our Word, and this is the object that I'm going to be showing how to manipulate. First thing, I want to know what object I want to be manipulating, or basically what object I
Yeah,
want
yeah,
them
yeah.
to
Dual line
present
trace.
our word when I press the number 1. As you can see, I am creating a line trace by channel and is hitting something like that. I'm going to be showing how we can disable the gravity as well. So for now I'm going to make this, let's say, 10 times heavier with the number 2. Compile it, save it, let's go into our word. So I'm pushing this forward, then I'm going to press the number 2, and now it's this too heavy for me to push it. Now let's press the number 1 and should be going back. Yeah. So now it's a lot lighter than before.
Okay, sure.
And then go back to 10, just like that. So this is the first type of manipulation that we can be using. The next one, I'm going to be showing how to disable the gravity. For that, let's go into our BP object, and I'm going to be creating another custom event. This custom event is going to say, let's say, disable gravity, like that. And then I'm going to have one input. That you can just select these comments and also make it show BP third person character. Let's just make a few comments. So this is to change weight, light, and this one is for change weight, heavy, like that. You can just select these comments, and I'm going to just begin to give you this small. Here I need to make it either on or off. So I'm going to just be leaving it as off by default. So compile it, save it. Now let's it down here, back. So this object. You don't need to be using cast for gravity. And I'm going to set gravity. So I could set gravity scale, and I think would be the best option for this. So right now it is at 0, actually it is at 1, but I'm going to be changing it to 0. Then let's say a little bit later on, I'm going to just get a delay over here.
Wait, I didn't see that though. Oh yeah, derp. There it is right there. It actually makes it more of a pain because it's probably Earth's gravity. Um, Gravitational accelerator on Earth's surface. 9.8 meters per second. 9.8 meters per second. Okay. So that's our baseline. So at 1, this is 9.8 meters per second. So what we basically got to do is divide this by 9.8 meters per second. It's in centimeters. Um, Analyzed bench gravity scale. but that's per second. Don't forget we're scaling by the update frequency. So it's actually I think that's right. So this is per second, but we're dealing with a tenth of a second, so we have to multiply it by our update frequency. I think that's right. UE5 set gravity scale. I'm sure we'll have to set up the animations and shit. Like, I'm virtually certain that all the animation stuff we did is going to have to be reworked to work with custom gravity, but I think it's just a matter of replacing all the z axes with like the character up axis. All right, so we set the gravity scale. Okay. Set gravity. Here, let's just get rid of this one for now. We're gonna just I think in the case of this, we can just. So velocity change. We can just use this. Should work. Okay. So this is our gravity component. So let's test something. I'm going to set this up so that we can like enter it, right? The only thing about OBS with Unreal is sometimes it makes you lose your cursor. And it's really hard to do this kind of stuff without a cursor. Alright, there's our player start. We should be nice and free of the gravity influence zone. And then let's go ahead and copy this, create a sphere, paste this in the middle, and let's make this 10. Yep. Okay. And let's go into our third person actor and add our component. Okay. Component. Okay, and now we want to hit a breakpoint. Um, Greater than 0 branch. If we have one or more influence zones, then we're going to pass here and we'll set our breakpoint right here. Let's try it. Okay, we hit that, so let's toggle this breakpoint and let's let Jesus take the wheel here. Shoot the planet. Wait, shouldn't have been firing like constantly. Crapped out. Oh, you know what? Go to our gravity influence zone that we made over here because we added this, but we just put bullshit in here. Location. Now we set the gravity to be the center of the sphere. Oh, nope, we flipped it. Hold on. Okay, so we still have to update our z-axis animation stuff. Are we orbiting now? Um, 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 uh. But we accidentally discovered how to put ourselves into orbit. That's fun. Pretty fun. Okay, so uh location. So this gets us the right direction. What were we doing? Okay, this was 980. Gravity component. Yeah, okay. I think that's right. So shooting the gun, is this applying like an impulse to our character? Shoo. Can I slow it down? Trying. All right. Let's do something else. Jesus Christ. I have a two body problem. um, okay, it threw us down the kill Z. It's pretty cool. It's not perfect, but it's alright. This fucking OBS cursor problem is killing me. Um, it's pretty hilarious. Okay, actually made it back. So we could actually go ahead and make this apply the gravity our character has when he shoots the gun to the projectiles. But I'm not going to do that quite yet. I'm just thinking. Because this is clearly not exactly right. It is kind of cool, though, that we basically got orbits. A pretty decent amount of progress for the day. The main thing was figuring out that little gravity component idea. I didn't save this. Figuring out the little gravity component idea, because, like, I didn't know how to make this universally applicable to all the stuff I wanted it to apply to. But basically, we just add this one little component to anything, and then it automatically adapts, or it automatically works with the influence zones. To apply a simple fall off. So this would just be a linear fall off. Oh my god. I'm gonna try something. We're gonna futz about with something real quick. Our gravity scale is way, 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 way too high right now. Like, omega too high. So whatever we're doing to calculate this is not right. Let's just do this. I'm curious. I would like to know what the gravity scale it's trying to use is. So let's take a look at the current vector magnitude and the log. Oh yeah, it's way, 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 way too high, and it keeps going up, which is wrong. It's not getting zeroed out. That's what it is. Check it after the normalized step. See, it shouldn't still be increasing. And we do this here instead. I don't understand how it could be increasing constantly. Like, this is clearly why it was, like, catapulting us. Firing our Vulcan machine gun while slip sliding around the sphere. Hmm. My brain is getting foggy. Uh, Too much thinky. Brain hurty. Okay, get rid of this. Default gravity, scale, acceleration, UE5 go. Gravity scale. What means playful gravity? Default gravity for the game's project settings, physics defaults, override gravity per level, world settings. Mathematically realistic if you know 1 unit of game dimension equals 1 centimeters. Is way too floaty. Number of project settings. It's not remotely realistic in the game rush. Eight times default. Negative 2744. Interesting. Um, let's take a look at this. Okay. Saturate. No, no, no. I guess there's no such thing here. Clamp. Fine. Max. 0. Okay. Something drastically wrong with that. Let's try that. Fuck. It's trying to jump on the damn wall. Okay. Here's what I think is going on. Ah. So it's closer, but still not exact. This would be 100x gravity. Let me try something. Should be 9.8 meters per second. No wonder it was shooting us into fucking crazy orbits and shit. And it ramps, it ramps, it ramps, it ramps, and now we land. So we have two problems now. It's continuing to climb linearly without resetting. Problem number one, which means that like as soon as we break free of this thing, we go flying. Um, Problem two is it's still not correct. Does it ever max out? Doesn't seem to. We could stand on one if I. Oops. If I were to say, take this guy and this guy, and then control click this guy, move this guy way down here, and then turn off kill Z. Stop it. I want to drag. Oh my god. The OBS cursor thing is killing me. Do this. World settings. Kill Z. A little bit bigger. Actually, let's go ahead and delete our safety barrier. Can I run into this text? That's fine. Yeah, we're already at 5 times, 7 times, 8 times gravity. We can't even move. Okay. This doesn't make any damn sense to me. Wait. Wait just a second. It does make sense. It absolutely makes sense. Before we do this, so basically, here's what we're doing, right? I figured out what's going on. So it wasn't the fact that we weren't clearing our data, our like gravity data. It was that we have this array, and this array was just stacking the highest influence zone every time this check happens because we were never emptying this array. So basically, we figure out the highest influence zone, we add it, we do our first calculation based on it. We loop back around, we find it again, but we haven't cleared out our array. So we add it to the array again. And now we have two influence zones that are both contributing. And remember, they have the same priority, so they're going to combine, but it's the same zone. So what it's actually doing is doubling its effect every time. So I bet if I add this right before we go into this loop, that all of a sudden it's going to look a lot better. Yeah, now our gravity is too low because we were doing weird scaling shit to try to make it work. And that's the ticket. Okay, so That is it. So now we just need to re-add or update frequency multiplier here. And now we would be at 1 at the very center, but since we didn't take like the surface radius into account, which we will have to add to this, but like I was just trying to get something quick and dirty in place. Since we didn't do that, basically we're stuck at 0.83 because that's like the percent of the radius in our linear fall off that we are. Okay, I'm pretty satisfied that that's working correctly now. Um, we can jump again. We have low gravity. Firing our Vulcan projectile machine gun. Testing out uh, performance of many projectiles at the same time. All right, so a couple things. Let's go fix our gun. Okay, what's up, dude? So, oh, it's a whole thing, but basically, I need adaptive gravity that allows, well, I don't need it, but I want it. I want adaptive gravity that allows for a few different features. So I've already made the modifications to the third person pawn in my other project to like make it animate properly with directional gravity. Um, so we basically want like an abstract gravity influence zone and then a gravity component. We can attach the gravity component to any object that we want to interact with the gravity influence zones. And what happens is on a timer, the gravity component will query any gravity influence zones it overlaps with. It will get a set of the highest priority zones, so one or many of whatever zones have the highest priority out of its available zones. It will then calculate a gravity acceleration vector um, for the combination of those zones, and then it will use that vector to set up directional gravity for the component it's attached to. The idea here being that I could have like a spaceship with a box gravity custom implementation that's just a no fall off, just a down on the z axis down on the z-axis while you're inside with a priority of 2, right? And so you could make a big ship, and on the interior of that ship you could add a square gravity influence zone, priority 2, gravity directions down on the z-axis, acceleration is just a earth constant. And that gravity zone could be nested inside a larger gravity zone that covers the entire earth with a priority of 1, with an actual like exponential fall off the same way actual gravity works, and a direction always facing towards the center of the planet. Okay, so you have those two things, right? When you're outside of the ship's gravity zone, you're affected by the planet's gravity. But if you board the ship, now you're affected by the ship's gravity, and you can walk around inside the ship, right? Like the ship could be flying around affected by the Earth's gravity, while you're walking around inside the ship's gravity zone, right? And so that's kind of what we're futzing with here. So what we've done is we've got a couple gravity zones here set up. Just a very basic implementation. It looks like this. Um, We take the world position of the point being queried, and we would probably put mass in here too, but I'm just doing world position right now. We get the world location of the center of the gravity zone. We get a direction towards the center, and that becomes our gravity direction. And then I'm just doing a really simple linear fall off here. So basically, the distance from the world position to the center over the scaled sphere radius. So if I'm at the max of the radius, this would come out as 1. And if I'm at the very center of the sphere, this would be 0. And then I do a 1 minus max was 0 and multiply by roughly the Earth's gravitational constant of 9.8 meters per second. And we return that as the acceleration here. So each gravity zone, really the only thing it does is have this calculate gravity data that you give a world position and potentially a mass, and it's going to give you a gravity direction and a gravity acceleration returned out of it, right? Then we have this gravity component, and this is a mess right now because I'm working on it, but basically we set a timer. I'm checking gravity every tenth of a second here. Uh, in check gravity, we reset our accumulated gravity vector. We fetch all overlapping actors with the owner's actor location, the owner of this blueprint component or actor component. So we get the parent's location. We do a sphere overlap. That's with a filter of gravity influence zones. So we fetch out the set of gravity influence zones that we're overlapping with. We clear our current zones. We loop through the set, try casting each one. If it was cast successfully, we basically do a highest priority accumulation here, where we clear it and keep adding them till we only have the highest priority zones from the set. So our resulting influence zones here would be um, one or many of the zones from the set that all have the highest priority in the set. So if I had uh, 3 zeros, 2 1s, and 2 2s, the resulting array here would be the 2 2s, right? And then finally, we loop those gravity influence zones. Each time we invoke calculate gravity data, we create a gravity acceleration vector by multiplying the direction with the acceleration with the update frequency, which is a tenth of a second. And then we accumulate that into a gravity vector. So we had two zones pulling in opposite directions, for example, they would partially cancel each other out. Um, and then finally, we set that into the accumulated gravity vector. Once this loop's done, we come down here, and then we're just trying to cast the owner object as various types of objects that gravity can apply to, and then applying the gravity, right? So, like here, for example, if it's a character, we can set the gravity direction and the gravity scale, and then I'll have to go make the animation changes to change the character's up axis to align with the gravity axis. But that's kind of whatever. I'm just trying to figure out the gravity zones right now. And then like this is applying it to static mesh component, subcomponents. So one fun experiment, we can see that it's sort of working. Because if I jump down into this, I start getting gravity. I just have linear fall off, so like we're not getting fully to 1 here. But we do have about a 0.81, which makes sense given the size of the sphere we're walking on here. If I try to jump off, I can't. I get pulled back. Eventually, my character will align properly so that we'd be running around this thing like a ball. I've already done that once, so we can do it again. Uh, but one thing that might be fun is what if I... The fucking OBS cursor thing kills me. You see, I don't know if you can see my cursor, but like it disappears over the window. So it's really, really hard to select stuff. Here, let's do this. Up, 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 up. Okay, got you. Got you and you. Perfect. All right. So what if we overlap these two zones such that we can like jump between them, maybe? And let's move our player start to the gap. I think that's not in either one. No, it is. All right, so I'm getting pulled to this one. We both got pulled. But if I come over here, I should have. I don't know what it's doing. It's definitely having some impact, but because I'm closer to this one, there's a linear fall off. You can see that it's not just constantly 8-1, it's also like trying to pull me slightly back towards the other one. So let's do this. It's so difficult to just fucking deselect. Okay. If I move them like this, and then I select them both, and then I move these down here, and like over here. I have low gravity right now. Oh no, I've left the gravity zone, and now my gravity. Now I'm okay. Let's try again. This time without jumping in low gravity and flinging myself out of the influence zone. Yeah. So like it's kind of cool. Like we're getting pulled in both directions and it's enough to equalize with a little bit of input from us the pull towards either the left or right one. But since there's nothing there to intercept us, we're just like swoop whooping around the center of gravity that's split between those two. So like the center of the gravity of these two objects is no longer in the center of one or the other of them. It's in between them, right? Because they're both contributing to our acceleration, which is really cool. That's how it actually works, so that's what we want. It's interesting that it's alternating. I'm not sure what to make of that. And we can kind of snap to either one. Like Unreal has the ability to kind of move a little bit in the air, and that's like enough to like cross the threshold here. And if we actually had our character alignment stuff set up, which is probably tomorrow implement the directional character movement stuff, then we would be able to walk around on these spheres and like actually jump and shit instead of being in a permanent falling state. But we did get our projectile manager done, as you can see. We can handle many, 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 many projectiles now, and we can make them all physics based, which is neat. Actually, I wanted to fix that. Hang on. Projectile weapon. Default projectile velocity can come down from like actual bullet velocity. Actually, I was like illustrating that it can basically be a hit scan. Um, but like paintball velocity, be like 150 meters per second. Damping can probably come down a bit, 0.75 per second. Now you can see that we have physics-based, uh, physics-based projectiles. Yeah, we take radius into account. So it's right now it's just a linear fall off. So I just basically take a ratio of the character's distance to the center over the radius, which is a really naive way to do it. What you'd actually do is define like a surface radius, and that would be the same radius as whatever the internal object is that you're going to walk on, and that's where your max gravity would be. And for something like that, you would usually use like an exponential fall off function, which is how it falls off in real life. And then for things like a gravity block for like a spaceship or a vehicle, for that, you don't need any kind of fall off because you're just like, if you're inside the vehicle, you're inside the gravity zone, you're getting pulled downward, basically. Um, those are the two major use cases that I can think of. Oh, yeah, and I should probably change it from being like a actual Vulcan minigun speed to being an actual like functional automatic firearm speed. And I want to change like right now the automatic nature of the gun is handled in the character blueprint. I need to move it to the weapon blueprint, but that can wait. But I do want to fix this. I was playing around with making it like a Vulcan machine gun to basically stress test the projectile system. And I'm happy to say the projectile system is a champ. It's very good. The other cool thing about this projectile system is it already has the ability to integrate directional gravity into it. So, like, literally, all I need to do is when the character fires the gun, I can take the character's gravity settings and pass them to the gun, and then the gun can pass them to its projectile structs that it generates and sends to the projectile manager. And we should just automatically have different projectile gravity based on, oh boy, based on where what gravity influence the character was under when they shot the gun. So like if I was in space, I would have no gravitational falling. Like I would have no gravitational like arc down on any of the projectiles because we would have zero gravity. Um, I don't think it's feasible to calculate the gravity at each frame for each projectile, but I think that just passing in the character's gravity settings at the point that they fired it is probably enough for most cases. And then the other thing that I got working with that was why are these? Hang on. I thought I moved these further down. Come on, god damn it. There it is. I don't want him overriding the gravity until I actually jump into it. Yeah, so the other thing I did was I figured out how to get precise hits on the character models, which would be really cool for like blood splatters and stuff like that. Like we get exact hits on where it hit the character model, which is cool. We could use it for damage calculation, dismemberment, blood, or like spark effects. And those negative numbers are just the model health going down as it takes damage. I don't have any like death effects added in yet. And then another thing I want to do is add like an actual crosshair to the center of the screen, do a line trace from that crosshair, and when you ADS, I want to adjust the animation so that it's like pointing at the line traced point under the crosshair, and with a little bit of like jitter, but that should help, I think, with aiming. Wee! Oh, I missed. But now I'm in the limbo zone. We can kind of smoosh across. So the gravity's still close enough from this one to where we can overcome it. And as far as making the sphere bigger, we can actually try that. If I can see the fucking thing. Oops. Wee. Alright, we start getting gravity effects. It's increasing as we get closer and closer. Can I land on the surface? No, I missed it. Maybe? Come on. Get up on there. Can I cross? Cross between? I don't know if I can get it between anymore. Don't think so. Wait, jump. A jumper! And I get over to this one. So the fun part of this is that should be a pretty realistic approximation of the way gravity works between multi-bodies, which is pretty neat. Another fun thing about doing the projectiles this way is we can take like the remaining velocity of the projectile into like damage consideration. And we have some other controls, like we can control the max distance it can go. We can control uh, the rate at which the speed decays. So if we wanted to do, we can also submit either one projectile at a time, or we could also submit a batch of projectiles. So we wanted to do like a shotgun. We could create a batch of projectiles for the shotgun with slightly randomized like vectors, like directional vectors, all originate from the same spot, but like slightly randomized directional vectors. And bam, you have a shotgun. If you wanted to do like a fragmentation grenade, you could randomize like 100 different projectiles in all different directions. And then you could like set a max distance pretty low, like 20-yard max distance, or really, really fast speed fall off or something like that to decrease damage and have all the projectiles kind of fall to the ground as they get far enough away, that kind of stuff. All that stuff is pretty easy to do with this system, which is really neat. We could also do things like shoot a projectile in a big arc, and when it lands, it could blow up into other projectiles, right? So, like, I shoot this, and then when it hits, the hit itself could generate 10 more projectiles that, like, explode out. Um, there's all kinds of cool stuff we can do with this little projectile system. And I'm pretty sure this could handle, like, probably upwards of tens of thousands of projectiles at the same time, which is probably more than we would ever need, even in like a heated mini versus mini fight. You probably wouldn't have 10,000 projectiles in the air at the same time. So, like, should be pretty good. Now, is this thing going to get picked up? All right, come on. Land on top. Land on top. Shit. Okay. Somehow I'm standing. Very little acceleration here because we're in between the two planets. But I bet if I rotate around to the far side of this planet, the problem is it's big and I don't have any like good locomotion. I could drop on the far side. But yeah, if I go to the far side of this planet, I should have greater acceleration. The problem is that the center of mass of these two objects is actually in between them, which is how it would actually work. So not really a problem, but a little awkward. The gun actually feels pretty good. Like even without a crosshair, it's not too bad. Also, these are like it's basically a way to kind of get the best of both worlds. Because trying to use a physics projectile was dog shit. It was like really bad. Like just trying to like spawn an object and then punt it with like a high velocity in a direction. Like the collision sucked ass. But this gets like the collision benefits of a line trace with the ability to have like physics based stuff as well, which is cool. I want to do some blood splatters at some point. You know something? I feel like there's a niche that's gone unfilled for a long time. So I don't know if you ever played like the old Soldier of Fortune video game, but like, has anybody made like a hyper realistically violently gory multiplayer shooter in a long time? I know we've had stuff like Doom, that's like hyper violent, but it's like kind of cartoonish violence. Like just making a destructible mannequin that has like guts and stuff and then making a shooter out of that would probably be a niche that could like make a pretty decently popular little indie game. Like just a decent shooter mechanics, but with like hyper realistic violence. I know there's the body cam one that I've seen, and that one has some like pretty good stuff like that. But it's like that's the kind of thing where if you make it good enough, people will freak out about it and complain about it, and you don't have to market it because you just rely on people freaking out about it and talking about how violent it is to sell it. Like you just rely on the fact that you're going to piss people off for free publicity, basically. Let me see if I come to an equilibrium. Yep, we basically can't move anymore because we're in a gravity well. So that's kind of funny. So if in real life, right, you're flying through space in your spaceship, right, and you there's got to be a point in between the moon and Earth where like if you don't have any thrusters or anything and you park in that point that like you just can't move anymore because at some point there's going to be an equilibrium between the gravity between the two bodies, right? And if you get situated into that point, I guess they're in motion, so it wouldn't stay there forever and you would eventually be able to get away. But that would be kind of funny. Like, you, you're flying through space, you run out of gas exactly between two planets in a perfect spot where, like, you can't actually accelerate in any direction because you're in the center of gravity in empty space. Okay, so this is a big progress day. We polished off the projectile system. We got the beginnings of directional gravity system started up. I want to tomorrow. I want to implement the animation change. So there's actually a tutorial. I think I even pulled it up somewhere. This one. Um, so this tutorial goes over what we need to know to correct our character movement. The only problem is we did a bunch of custom animation shit. So actually, it might be a little bit more difficult. But if I remember right, it's basically everywhere where you would be using like a z-axis up calculation has to change to use the character's up direction based on gravity. And that's it. So you have to go into the C++ for the character blueprint. You have to find everywhere where they're just using like either a flat z-axis value, a world up value, and instead you use um, the opposite of the gravity direction as the up, and like it's mixed with the character's axes to get your right and forward vectors, I think. So you change that, and then your character up is always pointing up on the axis of gravity or the direction of gravity, and that fixes it, I believe. I have that one working for the planets project. So I could actually use that as an example as well. I'm going to take a look at it real quick, and then I'm probably going to play some video games. Eventually, I need to migrate this project, but it has some dependency issues with some of the plugins, which is like I could probably work through it and figure it out, but usually it takes me like a day to do that, and I just haven't had a day where I'm like, I want to fight through dependency issues today. You know what I'm saying? It just doesn't sound very particularly appealing to me right now. All right, so here's an example. Um, this project has a third person pawn with directional gravity. So notice we're under the planet. If I drop from here, it'll take us a million years to fall. But if I drop from here, and notice that even though we were underneath the planet, our up direction is looking up relative to the planet, and our down direction is looking down. Do I? Oh, I have the post process ocean shader in place here too. But yeah, we can run around. So like in the case of what I'm talking about, like trying to set up, like this is just hard set the center of gravity to the 0, 0, 0. Well, that's not actually true. I base it on the planet center, but um, instead of that, I would just have a big zone around the planet that defines the area that the planet influences. And while I'm in that zone, my bullets and my jumps and my running and everything would be relative to the gravity of that planet. So if it's a smaller planet, you would have less. You'd be able to jump higher. If it's a bigger planet, you'd have more. You'd stick to the ground more. Your bullets would fall faster. And then if I get on a ship, I can walk around on the ship and I can shoot bullets inside the ship and they'll be relative to the ship. And if I go into space and I hop out of my ship and I shoot some bullets, there would be no drop because I'm in zero gravity. So like that's kind of the idea. And then the gravity zone becomes a part of the like proceduralization harnesses that generates all this shit. That one's pretty cool. I can find it again. I can't. Very thick, thick atmosphere. purple. And I've, as far as the Planet Gen here, I've got pretty much all the noise formulas made for the most part, um, for the actual terrain, but I haven't done a ton of work on like the actual terrain master materials. Like I think I have one, but like this would look a lot better with actual grass textures, actual stone textures, and also it would look a lot better with some PCG like rocks and foliage and shit, which is another thing I want to figure out eventually is how to apply PCG to the vertices here, and then maybe um, sample it from like a secondary material to make biomes and shit. I just don't have the fucking time, unfortunately. Like I'm on break right now, so some time to get some of this stuff hammered out. But like day to day, it's hard to squeeze in enough time to like do this shit. All right, close you, save it up. I think I am gonna play some video games. Maybe play some Path of Exile 2. Maybe play some Magic. I need to let my brain rest a bit. There was another thing. I think I was mistaken. Yeah, I was. This is not the right gravity constant. It's 980. Yeah. Falling at the same rate as the shots. All right. Well, later.